So in this video, we are going to look at DSDA series display units from Autonix. So these display units are available with different type of input configurations. We are going to see today how to use this display units with RS485 communication type modules. So these are DSDA series which specifically support RS485 configuration that we are going to look into this video. For that, I'm having a demo kit with me, which has 5 display characters you can see here. So the first display character which we have is unit with model DS16-GT. So it is 16 display unit with green color, and T indicates that it is an RS485 communication type unit which supports 485 communication. So this first unit which needs to be selected, it has to be intelligent type. So that is the first unit or base unit you can say. And units that connect adjacent to this units are expansion units. Like that, maximum we can do expansion up to 24 units. Here we have expansion for 3 units. So we can see the model number is DS16-GE. E indicates it is an expansion unit. So for display position second, third, and fourth, we have this expansion. And there is a fifth unit which is only for measurement unit, and that also specifically for degree Celsius or percentage selection. So this is a different series which is DU16-G, which is for display units. Okay, so there are different types of units. Here we have selected it for degree Celsius and for percentage selection. Okay, so let's see how to configure uh, the display units and how to send data onto it. So we have provided a 24 volt supply to the unit and also 485 communication through the laptop we are going to test. So we have used an RS485 converter which converts RS485 to USB, and we have that data inside a COM port in PC. Through that COM port, we are going to read and send the data to display units. So before proceeding, let's look at some settings that needs to be done for proper communication of these units. I have opened up the user manual for the display units with RS485 communication. Yeah, so we can expand these units up till 24, and the units are available in 7 segment as well as 16 segment with different sizes. And in 2 colors, we have selected that RS485 communication unit. So we need to look at the RS485 input model settings. So on the main unit or the base unit of these models, we will find some dip switches, and we need to configure the dip switches for the communication settings. So we can see S1, S2, S3, J1, J2 till J16. Okay. And there is also a jumper over here. So this is not a dip switch, but these are 2 solder points, and these solder points either we can short or open. And here we can see there are 1 2 3 4 5 terminals. So it's a screw type terminal where you can connect wires for powering up the display as well as the communication part. So the jumpers that we saw, which is this JP1, the JP1 jumper, if it is kept open, okay, the device acts like in slave mode, meaning a master can send data to slave and slave device can simply display the data. Okay, so if you want to do communication with PLC and through PLC you want to send the data to the display device, you need to make the device operate in slave mode. That means JP1 should be open. Okay, but say if you want to operate the device, say if we want to operate the device in master mode, we need to short the JP1 solder points. Okay, so in master mode, the display units can read addresses of another slave devices, and whatever data is present in that slave address, it will read and display it. So all Autonix um, devices like temperature controllers, counters, pulse meters, okay, all of them can operate like in slave mode. And display unit, this display unit, if you operate in master mode, the display unit can read the data of these counters, PID controllers and all. Okay, so in this video I'm going to show you how to operate it in slave mode. Okay, so let's see. Further to that, we have settings dip switches from S1 to S3. So S1 is for your response time settings. Okay, so if S1 is on, response time is 20 millisecond. S1 is off, response time is 5 millisecond. Baud rate settings we can do with respect to S2 and S3. Okay, and from jumper settings, J1 to J16 are for selecting the slave address. Okay, so let's see in our case what is applicable. If we properly analyze our base unit, the switches S1, S2, S3 and S4 are all on. Okay, are all on the on side, whereas J1, J2, J3 and J4, so J jumpers or the J dip switches are all on the off side. Okay, so coming back to the PDF, S1, S2, S3 and J1 or were on the on side. That means our response time was 20 millisecond. Our baud rate is 38400 and the first jumper is on, rest all first J1 dip switch is on, rest all J1, rest all J2, J4, J8 and J16 dip switches were off. That indicates our slave address is 1. Okay, so using these communication settings, we will set up our communication. Then we have these 5 terminals in which 1 and 2 should be given 24 volt supply. So I have connected an SMPS, 24 volts SMPS, and 4 and 5 we can use it for RS485 communication. So how to send the data for these units? So for sending data, data input method is available. This page you can refer from the user manual, data input method. So in this data input method, the first unit which we have is base unit, and then we have the expansion units. So we need to send data starting from holding registers 4001. 4001. Okay, so when you send a data to lower byte of this first address of holding register, okay, you turn on zero blanking, and if you send data 000, zero blanking turns off. What is zero blanking? We will see. So the lowest byte of the first address of holding register is for zero blanking. Then the second address of our holding register is for the data for the first display. So data for the first display will go to the higher byte. Data for the second display will go to the lower byte. So two displays are handled by a single holding register. Okay, the next consecutive address of the holding register will handle the display units next to it with higher byte for the first and lower byte for the second unit. Okay, so let's say um, we have one base unit, then we have expansion, then we have one more expansion, then we have one more expansion, and then we have the unit display. So the first unit, if you want to send a data, that will go through 400002 address higher byte. Data to the second unit will go to the same address lower byte. Data to third address will go through this address higher byte. Data to the fourth display unit will go through the same address with lower byte. And data to this unit will go through the next consecutive address, that will be 400004 higher byte. Okay, so this is how the data addressing or the mapping will work. Let's verify this mapping by using DAQMaster as well as by using a Modscan software. Okay, so we will first check how we can send the data through DAQMaster. So after opening the DAQMaster, we can go to the supported device list. In supported device list, we can go to controllers and we have DSDA series. So once we add the DSDA series, okay, we can do the communication settings. Here we need to select the COM port. Our baud rate was 38400. Once done, let's connect and then let's scan the unit address. My slave ID was 1. So at slave ID 1, we are receiving the unit. Added the slave ID 1 address. Once we add this address, select this device and go to the property window. And here in this 3 dots, we have settings. Then once we click inside this DAQ space, we have configuration for number of units. So in my case, I have number of units, say 4 number of units and 1 display unit. I'll add the display unit or the measurement unit later on. So I have just selected 4 units. So you can see the 4 units are visible here. To send a data to this 4 units, you can double click inside here. A window opens up. So in this window, you can configure this 1, 2, 3, 4 characters, or you can send data and verify whether it works properly or not. So select the data, select the first unit, and let's say add user display. So this user display gets added, and here you can send data. Say I want to send a data 1, say 9 on the first display. Save it. Okay, so the data goes 9 here. Select the second display, add user display, send some data here if you want. Then I'll send say 9D. In the third unit, I want to send a data. Select that third unit, add user display, say 2. And in the fourth display, select it, add user display. Say I want to randomly send a data something like say T. Okay, and in the fifth place, so at fifth place, I also have a measurement unit. So we can just increase the number of DPU digital units here. Right click on this unit. Okay, and here you select unit segment. In this unit segment, you can select which unit you want. Okay, so in my case, upper side I have degree Celsius, lower side I have degree, lower side I have lower unit, I have percentage, or you want to turn on both of them, or you want to flash them. So all these different options are available. Okay, say I'll select right now upper unit. So degree Celsius only will be selected, lower unit will turn off. Okay, so save all this configuration that has been done. Okay, and close this and then go to run. So you can see in the video 92T degree Celsius is visible. Okay, simply for testing purpose, let's change this value to something else. Say 2. After changing, save it to 4 F S. Okay, you can see online itself it is changing the same way. And say if you want to change the display unit, right click unit segment. Say I want to turn on lower unit turned on. Want to flash it. Okay, it will keep on flashing. So this things we can do it from here. So this basically DAQ software will be used for testing it. Okay, but actually when we use this device in any application, the data will usually come from a PLC, not from DAQMaster. So let us test the same thing how we can do it with the help of Modscan. Okay.